So I recreated your file and I got the right answer, and it does agree even with the lateral loads. So for the game, this is what I thought of initially, and then you suggested that it wouldn't work for the lateral, but I think these internal forces, I've proven it already with the slanted frame. And I don't know if I showed you that from the IASS paper. Anyway, here's a delta of 1. Got to get the error kind of small. I leave it a little bit positive just to be cautious. And my F3 modern Mueller-Breslau and my F3 statics, are reasonably good. And obviously 10 and 10, 12 and 12, and 14 and 15. Now, if I reduce this down to something small, I think it's a little fussier because I'm dividing by such a small number. But, it's a little twitchier here. You could see it's a little twitchier. So now, and what I'm doing, I'm looking at my error 007 and modern Mueller-Breslau is 138. So for the game, we would put in 140, right? And, like what they would do is with a 1, so they would always be using a 1, and they would get it, pretty ding-dong close, and they say, okay, 140, they get 144. That's good enough for me. All right, how did I do this? Let me, first of all, there was just a little bit of messy, obviously, I'm a little fanatic about this stuff now. So let me just hide these and see if I could recreate this really quick. Let me just hide all this stuff here. And I think there was a weird thing on your file where the points, they weren't at, the left was not at 0, 0. Even the right was not at a vertical of 0. I don't know if any of that matters. But anyway, what I like to do, and please label your points. So left, just fix it, obviously, because I've done that many, many times. I've told you. You could also increase the numbers here if you want. Obviously for your report, you don't never need more than 2 decimal places. But when you're debugging, it's under options, rounding. So the first circle is stick 1. You drop a dot here. The second circle starts on this one, and that's stick 2. And then the third circle starts at the left. I think we talked about this already. And that's stick 3. And that intersection is the right point. So let's call that right point or something, okay? And then you could draw your segments. I've been using the gray for, and it doesn't have to be dashed, but I've been using the gray. I'm obviously doing everything in black and white for the book, but now you've created a linkage. That's called a linkage. So it's, unambiguously the right lengths. You could always check this, which I recommend that you do, just showing the value, just to kind of keep that, so it's a reality check. Now I put in the slider for delta, and then you had a couple like a delta 1, and a delta is always your perturbation. It has nothing to do with the error, okay? So I'm going to hide this right now. Delta is your perturbation, and your error is just going to be, I don't even really need this, but I'll just show it to you. The vertical distance of your new right point, not this old one, it doesn't matter. This is just a picture for reference, so I'm never really using this. But I'm going to make it such that the right point is just about 0. So here I'm looking at 0145. 01, yeah, okay, that's close enough. 12 and 001. So I can't make that exactly 1 with this technique. Oops, but that's fine. Okay, I hope that makes sense. All right, now I could actually fix this. I could rename this as crown 2 or something, and I'm going to fix this crown 2 so that I don't accidentally wiggle the right. So now I can't accidentally wiggle the right point. So everything's dialed in pretty good now. I'm going to call that crown 2. Now the new circle, and that's stick 1. And you're just recreating the steps now. Hide this one. The second circle is going to be stick 2 plus delta. You did that correctly. Stick 2 plus delta. And the third circle is stick 3, starting at the bottom left. And now we have a new linkage. And I'm going to call that right point prime. Right point prime. All right, and then, you know, obviously hide. And I'm not going to draw the forces in here now. But the forces are labeled, and I could change these colors here easily. You could do it right from here, which is kind of handy. I called them F to the right and F down so that you're unambiguously, you know, FY could be up or down. So F to the right is unambiguous. FY is ambiguous. F down is unambiguous. So they're both 100 here. The error now, my new error, is simply Y of right point prime. So, oops, right point. Okay, I see it. I made it oopsie poopsie. All right. So that's my error, and I like to just put that in as dynamic text equals error new. All right, and then I'm going to try to drop that, and I got the line here for a visual help, but I don't really need the line. I could just hide the line. It's actually not helpful, really. The key is slightly positive, okay? And then the nice thing about this is you could also call this crown 2 prime, for instance. Crown 2 prime. Just you know, good habits of programming. So crown 2 prime clearly went up. You could see that it went up. Crown 2 prime clearly went left. You could see it went left. So those are both negative work for the down and the right, respectively. So that become positive on the new in the work. The stretch, though, is always negative. So that's something that I think you and I talked about, but maybe you forgot, or maybe we haven't. I thought we talked about it in the truss. The internal work is always negative on the stretch because if you elongate it, your force is pulling against the elongation. If you shorten the stick, your internal force is pushing against the shortening. So it's always negative. So F3MMB version 2 is always the negative on the internal one, and then the external one depends on the situation. But the external was negative, so that became positive when you bring it over to the other side. So that's why it's negative. If that's not clear to you, let's talk. So then it's F right. Oh shoot, I didn't put the lofts in here. So let me put the lofts in here. Loft right is X of crown 2 minus X of crown 2 prime. Yeah, you could put those segments in, but they're just visual. For your debugging, I think this is easier. The loft Y, or loft down, is Y. And now here, be careful with the signs. And maybe this is where your mistake was. I should take a look at it. You want to make sure that this is positive. If you're programming it as positive, and when you're using a segment length, it's always absolute value. It's always absolute value. So let me just save this here and show you what I mean here. When you, I tried to debug your program, but I couldn't quite. So for instance, I put in an error absolute value, whereas you put in an error and it was just the segment. It was just the segment, and that is, well, I think your movement was here. This segment is always positive. So, I don't think the error was, maybe it was that, or maybe it was your Y crom. Let's just take a look at this for a second here. For a positive stretch, oh, wait, now something is funny here. Mine went the other way. Oh, wait. This is yours? Well, now I see your error. Your whole configuration is wrong. I don't think this is... This should be 12, right? And it's 13. How did that happen? Wait a minute. So, okay, I found your error. I don't know exactly what happened, but this, that was supposed to be 12. So something got screwed up on your circles here. That's your error. Okay, so now do you see your error? This was, you can only change one, oops. Oh, wait. Oh, I'm confused. I thought you were looking for the... Okay, sorry. Bah, I thought you were looking for stick. I thought you were looking for the diagonal stick. Maybe you were looking for the horizontal stick. But that's weird too, because you based your... Something's weird here. Hang on. F stick 3. What's F stick 3? You have it as, well, that's me. F theory. I can't figure out your theory. Well, if you're looking for the stick on the top chord, that's easy based on our roller. If you're looking for the stick on the bottom chord, that is not easy based on the roller, because you need to get the stick. You have to do, so that's a terrible free body, right? You can't, I would just, well, you understand what I'm saying. You get the theory of the roller. That's a vertical force. That's quick to get this stick on the top chord. And then you could get the bottom chord, but it's a two-step process. So maybe that's your error. I'm sure that's your error. Anyway, so mine, going back to mine, just label things once, make sure that you've got the stretch. So even at 1 here, my force MMB is not good because of the boundary condition violation. So I think I mentioned this before. The boundary condition is super important. Now what happened here? Oh my gosh. F3. Oh, sorry, I'm tweaking the wrong thing. So F3 MMB new is negative F right times L right plus F down times L down divided by the delta, which I called the stretch in your other program, but I think it would be better. Oh, Lord. F right times L right. Okay, that doesn't look right at all. times L right. Alright, so what is this? This doesn't look right either. Crown. So my lofts are wrong here. L down is, y of crown. I made it. I just didn't finish here. Y of crown 2. Oh, I think what I was talking about was positive. Y of crown 2 prime minus y of crown 2. That is my loft down, and my loft to the right is x of crown 2 minus x of crown 2 prime. So what I was saying was that the lofts are easily programmed. I just didn't finish the one. And now you could see for a small error, even at 1, I'm pretty close, right? So I would call that minus 140. And then as I make the perturbation smaller, you're right that it should have been more exact, but I think it's a little twitchier. I think that's the only problem. And here, you know, I'm at 100, so I am closer, right? And zooming in doesn't help. I think the error is really helpful here. I would recommend doing it to 4 decimal places or something just to kind of see. I would recommend keeping it ever so slightly positive just to keep, you know, your debugging. And now I'm a little bit off there, but you know, I think the answer is 140, right? So there we go. Yeah, and now you could see 141, and so everything works. So I think there was something crazy that happened in your program. But here's the really good news. In the board game, we could have horizontal and vertical loads. They can be left or right. That's what I said, and then you confused me. Be methodical. Make sure that the left is at 0, 0 always on your points. Then fix things when you're kind of get it locked in. Remember, I fixed the original crown. This right point is just for visuals. I never use it. My error is the vertical error of the right point prime. Y of right point prime. Y, and you'll notice in your file you had your right as being a little below 0. I don't know why that happened. So on the game board, then, when you do get to the game board, which I think you know is going to be super fun, right? You don't need to show the axes, but on our game, there's going to be a triangle on the lower left, and that never moves. And then you've got your sticks, and obviously you're always going to be using 1, and the kids will just get close enough like this, and they'll measure. Now this is the problem, you know, measuring that vertical loft, you know, that's 0.1. You know, can they see it? You know, maybe like if that grid line is a 1/10, you know, they would call it a 1/10, you know, or something, and you're multiplying by 100. So so I think this is good news. I think everything works exactly like I said it would work. The bad news is that you made some errors, but everybody makes mistakes. Hopefully this helps. Without a video, it's a little hard, which I'm hoping I can get some videos in the book. Okay, good luck.